Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad Iqbal bin Anwar. My maths number BF20802. In this video, I will explain the flowchart for the moment distribution method, which is an important technique in structural analysis for continuous beam. For the step 1, the first is to input all the required data such as load acting on each span length, and the moment of inertia for each segment. This value are essential for the next calculation. And the second step, calculate stiffness of each member. We calculate the stiffness for each member using the formula K sama dengan 4EI per L or 3EI per L, where E is the modulus of elasticity, I is the moment of inertia, and L is the span, the length. And step 3, calculate stiffness at each joint. We add up the stiffness values for all members connected to a joint. This total stiffness will be used to find the distribution factor. And the step 4, calculate the distribution factor. Distribution factor are calculated by dividing the stiffness of each member by the total stiffness at the joint. This factor determines how much moment is distributed to each member from the joint. And calculate fixed end moment. We then calculate the fixed end moment for each member. FEM represent the moment generated at each end of a fixed beam due the external load. Step 6, perform moment distribution. Calculate the distribution from 1 to 7. Now we start the moment distribution process. The unbalanced moment at a joint is distributed to the connected member using the distribution factor. Then a carryover moment is applied, where half of the distributed moment is transferred to the far end of the connected member. This process is repeated several times, up to 7 cycles in the flowchart, until the moment are balanced. Okay, for step 7, calculate final moment total. After all cycles of distribution and carryover are completed, we sum all the moment including the fixed end moment, distributed moment, and carryover moment to get the final moment at each end of the beam. Okay, step 8, calculate reaction. With the final moment known, we can now calculate the support reaction. These reactions are necessary to ensure the structure is in equilibrium and safe. For final step, print result. Finally, we print all the calculate moment and support reaction. These results are important for structural design and analysis. Okay, that's all from me. Thank you.
Okay, for support reaction, we have 3 loading. For first loading, we have 10 kilonewton. First, we calculate the moment RAY times 5 minus 10 and time 5 and then time 5 over 2. And then for RAY, we got 25 kN per m. And then we calculate for FY. For FY, RAY plus RBY minus 10 times 5 equal to 0. So 25 we plus with RBY minus 50, and then we get the RBY 25. And then because this support have 3, so we need to calculate Fx. So Fx equal to 0. And then for second loading, we have 25 kilonewton per amp. So we calculate moment equal to 0. We minus RCY times 5 plus 25, we multiply with 5 and then 5 over 2 equal to 0. So for RCY we get 62.5. For FY, RBY plus RCY minus to 25, we times with 5 and then we got 0. So RBY plus 62.5 minus with 12.5. So we got 62.5 kN. And for the last loading, 20 kN. For moment C, we got RDY equal to 50. And then we calculate for FY, we got RCY equal to 50.
Okay, so I will do demonstration about how I create this program and how we running it. This program is about to calculation using deflation method for structures analysis. First, as you can see, for example, for the load A, we just input value 10, B 25, and C 10 and D 30. After that, we just need to input value of length, which is for span A, B, BC, CD, and CE. Let's say 5, 5, 5, and as you can see, this is unsymmetry point load. So we just need to input the value of AX, which is 3. For the BX, we just need to the rest of the length, so 2. And for elastic yang modulus, if the value of EI is constant, we just need just put 1, all 1. Okay, as you can see, all the calculation is automatic. Kawan, tu je.